3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really
totally
is.
agree.
Level. It really is.
Level.
And bam, there's the radius of the Earth.
I made a shocking discovery today when I was hanging out over at MEUK's Discord server.
Are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, did you hear what I said? It's all about...
Have you come to defend any of your mates, whatever?
Yeah, I was just going to say, with this equation, it shows both how the big enough circle can be incredibly flat, like
Where?
nearly perfectly flat, and curved at the same time. Circle.
What?
I put in 10 feet, so the first number is the radius of the circle, and then the radius is squared. Take the square root of the radius squared plus the half of the distance of the chord. Yeah, I was just going to say, with this equation, it shows both how the big enough circle can be incredibly flat, like
Where?
nearly perfectly flat, and curved at the same time. Circle.
What?
So the one that I have up there,
Sorry, say that again. Did you say perfectly flat?
I did, yes, because
That's
if you,
two-dimensional, right?
if you look at the equation, which I mean you'd have to open it up, but I put in 10 feet, so the first number is the radius of the circle, and then the radius is squared. Take the square root of the radius squared plus the half of the distance of the chord. So when I plug in 10 feet, so I'm thinking like a plate glass window. You know how you're always talking about how you make a window and they just pour it on top of liquid tin or something like that to make it perfectly flat. So if you use that Wank and Wolfram alpha, put in 10 feet, and since you can put in your units of measure, it does all the math for you.
Okay.
It shows.
Yeah, I understand the math, right? Can we go back to your picture that you gave us, right? You've got some lines. Did you label any of those level and horizontal for me?
I already told you that it doesn't matter at this point.
No, it definitely does matter, because that's what you're talking about, right?
So,
you are talking about level and horizontal here.
So if you use the equation for the sagitta, let's say you got a 20-foot piece of plate glass.
That's on a circle, right? A sagitta is a measurement for a circle. Okay?
Exactly.
Right, okay. Now, we are talking about level and horizontal. You've shown us a picture of a circle. Can you label on that picture which line you imagine as being level and which line you imagine as being horizontal? Please.
I won't go back and label it because it's just a sketch and I threw the paper away, of course.
Well, you can just copy it and put A and B, draw it on there. I can draw it on there, right? I could do that. Just please label A and B. A is level, B is horizontal, please. I just need to know that we're talking about the same thing and you understand what horizontal is.
No, what I'm talking about is how you can calculate sagitta, which on a circle.
Yeah, that's on a circle. We all understand that. We can do circular geometry. We can work through book 3 of Euclid.
I'm just going to drop any pretense. What the circle represents is the cross section of the Earth. So it's based on the radius of the Earth.
Okay.
Okay,
now
can
the
you go back
first
to your
number,
picture like Bev asked you?
Right, yeah.
The
Level,
first number-
horizontal, please. Label it on that picture.
First number is the radius,
Hello.
and
No.
for
Hello?
Is he
still
preaching?
here.
Yeah.
So
Are you
if
preaching?
for
you
a piece
answer-
of plate glass window, if you plug in, the cord would
Look,
be 20
I'm
feet.
putting it back in the debate discussion. See that picture? That picture, label the lines for me, please. Level,
First,
horizontal,
okay,
please.
if you listen for a moment, and I'll
No,
go
no.
back and
No.
talk about that.
Why are you gonna? Are you preaching to us?
No, I'm
He
not.
asked you a question. We're trying to. Right here, you dropped the picture. We're just trying to see where you're at on this picture. Can you go back to that picture, please?
So on a
Hello.
piece of plate glass window, the
No, see,
sagita
there's straight lines
Sagita
and
is
right angles. That's all I know about
a
that.
red blood cell. Now, that was the proof, which just shows that the drop. and
It's
you know
that's
what the drop-
circular
Hello?
geometry, right?
Okay.
Yeah.
Scripted.
You know when I say the drop, you're normally talking drop from horizontal, right?
No,
So-
no. That you're talking about a circle.
Yes.
Okay.
And this is to show you how that
Right.
drop from horizontal starts out
Which
being
which line
almost
is
nothing.
horizontal, please? Label it. Label
I'm
level
fixing it.
and horizontal, please. You are trying to show us a picture of a circle, and you are trying to reference that with the Earth. Please
You're trying
label
to get me in
your
this infinite-
picture.
$10.
You're trying to get me in this infinite loop discussion.
No,
on
I'm trying to get
label
you
No.
to label your picture so we know what you are talking about. It's your picture. Label
I'm going
it,
to-
please.
I'm going to describe. Okay, the line on top. It looks horizontal. It just tilted a little bit. It's the same one that
No,
everybody
you
uses
can't
for
have a
horizontal.
tilted horizontal. Sorry.
I just tilted the drawing. Okay, wait. What am I doing?
Ma'am,
No, I-
$10.
I-
$10. He never
purposely,
labels this.
Yeah, definitely. He won't. He won't.
Because it's a
Never
proof
label
just
the
to show
picture.
that the two triangles are the same. That's all.
What?
That's the only
Which
information
triangles,
I'm trying to relay.
please?
So the triangle that's made up by the sagitta and the drop.
Where's the triangle? I can't see any triangles in that picture. Sorry.
It's a quadrangle.
Can you
So-
can you label the triangle? Like you've just referenced the triangle. There isn't even one there. I want a horizontal now, please, and a level, and now please label triangle A and triangle B.
Okay, this is good information because what I'll do is I'll make a video later. So it's a quadrangle. And so if you connect a
So
line,
if you go back to your picture, can we get that, please?
Yeah. Yeah. The missus is asking me if my head hurts for all the brick walls I'm hitting with it.
well, the whole point of that is just to show that instead of
Okay.
using
can you go back to
eight
your
inches
picture?
per mile square, which is
Hello?
not.
Let's
does
talk
not
about your
describe a
picture
circle.
and how you're not labeling your picture. You're just drawing a picture.
I don't have much more time. I'm gonna have to get ready for work.
Oh, okay.
Oh, yeah.
Next time you come with a properly labelled picture, then we know what you're talking about.
I'll save your picture, so next time you come here, I'll bring your picture back up.
I honestly, I know this is really hard to describe.
No,
No, it's not.
It's not that hard.
Label it up and it'll be dead
Describe
easy.
it to other people, and now I try to describe
B.
it to family members, and they don't understand what they're looking at either. So I'm not exactly a math teacher. I don't have a whiteboard where I could walk up and
But,
label.
I'll give you a couple of hints, right? Label your drawing up, then people can understand what you're talking about. Don't talk about triangles that aren't even there on the paper.
So can you let me at least get to my last point?
You have a point.
Wait.
I've got to go to the
There's no
toilet
point.
anyway.
We're talking in the, you're talking in the air.
If you use the equation, the Wolfram Alpha equation, where I put in 10 feet, you can put in any number you want, and you put in the units of measure, and it'll tell you what that sagitta is. So this is a tool.
Wait. The way you're talking right now, I want to put something on paper so I can write it down. What am I going to put on paper? What am I looking at?
You click on the Wolfram Alpha link, which is further down. It says Wolfram Alpha. If you just click on that, I have the equation for the sagitta in there, and where it says 10 feet, this is a tool, and you can put in any number you want,
so
and it'll give you the sagitta.
Cool.
And
why
so
are you not labeling your pictures?
Because it doesn't have. Like I said, if I do a video, I'll put some labels on there. Plus, I got to learn how to do a video.
Well, I mean, that's cool. Why can't you label your picture right now?
Because ultimately it's the equation what matters. It's a tool, so instead of everybody says 8 inches per mile square, it doesn't describe a circle. But this not only gives you the drop, but it also gives you the sagitta, which is the hump that people keep talking about.
Okay.
And then
so come back next time. It's cool.
And then my point is, when I did it for 10 feet,
I will save your picture.
10.
I will save your picture. And
next
time you come back, I will bring your picture back up and we can talk about it.
So if you put in something like when I put in 10 feet for the sagitta, Wolfram Alpha calculated it, and you can calculate it on your calculator. There's nothing magical about Wolfram Alpha.
Yeah. So
it came up with a sagitta that was less than the diameter of a red blood cell, and it tells you it compares things.
A red blood
on the
cell.
bottom, it compares the what you calculated with different things. So on a plate glass window, sagitta is less than the diameter of a red blood cell. So it's perfectly flat.
Emma.
Now, if Bev is...
Can you hear me?
Yeah, we can hear you. He's doing Pickle Rick, right?
So
yeah.
If Bev is standing on the side of his canal, and he can see 1 mile, so in that 1 mile, the sagitta is 2 inches, and you can just type in 1 mile there.
So I'm just gonna keep on talking.
The sagitta of what?
You know what the sagitta was. You were the one that...
but you're going to now pretend that the sagitta is coming from where? The chord.
Yes.
Right, so if I can see a mile, then can I see the chord? Can I see through that sagitta? Right?
Oh,
is that what you're saying?
You can't see anything but you could see a mile, and you're looking at perfectly flat water, right?
Right, okay, so over that mile, right, you're imagining that the other end is level with the point that I'm at, over a mile, and all we're talking about is the sagitta of the rising water of, 2 inches in the middle?
That is correct. And that's the way it is on the Earth.
Okay, so that would be sagitta would be to a horizontal, right? So are you imagining the chord is horizontal?
No, the chord is not horizontal at this point.
Right. So where is the horizontal then?
Horizontal would be like your would basically be a line that's tangent to the circle.
Oh, so that's the one on top of the circle, right?
Yeah, that's your eye. It would be like your eye level, but it would be starting at your feet.
Okay, so the chord then is a constant drop away from the horizontal. See, it would have been loads easier if you had labelled your picture yourself. Then you could have put on it horizontal and a big line to this one here, and then you could have said this is level here, and then this is the drop from the water level drops away from the horizontal. Couldn't you?
Right.
Right, because you are imagining that the water level, right, is a curved level. Yeah? That's your curved surface, right? Whatever. The water level is the curved surface that drops away from the horizontal, right? Whatever.
Canal is. Yes.
Yes, did you just say?
Yes, the canal is.
Brilliant. So we've got a tool that establishes a horizontal line of sight, and we can transpose that horizontal, and we can measure, like Jesse Kozlowski says, we can measure the drop.
You have that tool. You have an auto level.
Yeah.
Here's another point I want to make. You got 100 feet of, or 100 meters of hose, and you want to use that to set up some kind of an experiment.
No, not an experiment. No, why would I want to do? What's an experiment?
Oh, okay, whatever. I like that. But for your auto level,
Yep.
using this math, drop is like at 100 meters is 1/32 of an inch.
Yep.
And if you can measure, like half the thickness of a coin at 100 meters away accurately, you could measure the drop.
Right, Sly Sparkaynes, right, has a bending water level test, and he has 16 100-meter water levels like that, right? So now you've said that is just what? How far did you say the drop was? 32nd of an inch, right? So 16 meters. Of all of them together will add up to what? Half an inch?
No, that's the point. It's not linear. It's not like rise over the run. It's an exponential equation.
Okay, so when he lines these 16 100-meter water levels up against each other, will that work exponentially?
No.
Because you said that individually there's only a certain amount of drop that you're imagining. Because I'm imagining both ends of the water level to be horizontal.
So if he measures a drop at 100 meters, then moves his auto level to the next. No.
Sly Sparkaynes' test is just to put 16 100-meter water levels together. The tubes. He's putting them together, not joining them up, just making a 100-meter water level, bang, put it down, and then start the next one from the end of the first one. So he's going to go like a mile, but in 100-meter increments. Now, that water level that's 100 meters, right, is that a local 100 meters? So is that drop individually from the start of the water level to the end of the water level? Because I know that is a horizontal plane, right? But you imagine some sort of a drop.
How many? Let me try this.
16. It's 1609 or something like that for.
So 1600 meters.
Yeah, 1609.344. So that's 1609 meters, 344 millimeters. Is about a mile. So when he's doing 16 of these 100-meter water levels, right, he's going to put them together. You imagine that each one of them is going to have a drop of 1/32th of an inch. Right, so 16 of them, I make that out to be like half inch. Would you be all right with that? Is that a good calculation? But that's over a mile individually. Like would that be locally level? See, that's why I think my one's better, because it goes over the full mile, whereas his just does it in 100-meter increments. And it comes across a few problems, right? But I mean, he's calling his a bending water experiment, right? So he is calling his an experiment. So you might be good to have a word with him. Sly Sparkaynes, that is. And he has bought an auto level as well to check, but I don't know what he's going to do with the auto level. He says it's not for helping him with his test, and he's not going to sight anything down with the horizontal. He's just going to do it with his water levels, right? So 100 meters. Yeah, I've got 100 meters of a water level tube. But you don't know what I'm doing with mine, do you? Well, actually, we could make sure it's horizontal, couldn't we? You alright with that? Do you think that'd be good? Like, if we could sight it at, say, I don't know, put it like 1 meter in front of us, and we can look at the one level of it, one end of it, and then check that the other end, 100 meters away, is at the same level. Does that sound good? Whatever. Have you gone? Do you think you've been muted? Nobody's muted you. If you, that's what you're going. You've just gone quiet. Can I get a mic check? Can everybody else hear me?
Yeah. It's Discord. Sometimes it just drops the sound for people. Okay. It's just Discord being useless.
All right, am I back?
Yeah.
I was sorry, I was talking.
Yeah, I know you were mid-sentence. It does that regularly.
So at a mile, the sagita is 8 inches.
What, at a mile? Sorry?
Yes.
Let's start again.
You can't add 100-meter increments out to a mile, the drop of 100-meter increments out to a mile. You have to do it from beginning to end.
Okay, so Sly Sparkaynes' test's rubbish then. I've been telling him that, and he said it. I've been saying to him he should have come and had a chat with us. But he wouldn't. He just kept saying I was wrong and I don't know what level is, and level isn't horizontal, and he's going to find the bend of the water level.
I don't know the point of putting water levels. Like, I don't know how you even see a mile away the end of a water level.
You don't. You don't need to see the water level. That's the beauty of a water level, right? Sorry, whatever. Right, no, don't just keep talking. I'm going to tell you now. The beauty of a water level is you do not need line of sight. Right? Once you fill the water level up with water, then the two ends establish a horizontal plane, whether they're together or far apart. You do not need to see line of sight.
If your two ends, if you're at one end and the other end is a mile away,
yep,
then your horizontal being your auto level would be 8 inches above the water on the other end. But there's no way you can measure it because you can't see the other end.
Well, we said that, right? But once you go all the way to the other end, right? Because that's what you do. You transpose the horizontal level from one end to the other. You know, you do know how people do surveying, right?
Yeah, exactly.
Yeah, okay.
And
so you understand differential leveling techniques.
Oh, yeah, differential leveling actually helps take away the error from any curvature because it's equal drop on either end.
When you say error from curvature, what are you talking about? Can you explain that to people?
I'm talking about the 32nd of an inch at 100 meters. But it would be the same looking both directions. And then you move it again. So you could differential level all the way, for miles and miles.
Yeah.
And it'll be the same as if the Earth was perfectly flat.
Yeah, horizontal, right? Because that's what you're doing. You're establishing a horizontal.
That's what your auto level does.
Yes.
I mean, the easiest way to see it is to take your auto level to a nice overlook.
No.
By the sea.
No. Whatever.
And just look at.
Have you got an auto level?
that?
Have you got an auto level?
No.
No. Have you ever looked through an auto level?
Nope.
No. Have you ever done any differential leveling with an auto level?
No.
No. So basically you don't know what you're talking about. Right now, let's just take it, imagine, right? Let's imagine there are professional people out there that do a job, right? Now, this job is called surveying. Now, their job is to establish a level. That level is horizontal. Now, that's important for people that, let's say they're making houses and they want to put drainage in, or, you know, like, imagine building a canal, right? Now, you're building a canal and you want to make sure that the water doesn't run out of the end of it. So you have to make sure it's horizontal, right? So you have to establish a horizontal to read your references from. You do understand that, right?
Yeah, I know what you're talking about.
Okay.
I'm run out of time, but if anybody wants to click on that Wolfram Alpha link and just change that 10 feet to whatever distance you want, it'll give you the sagita, and that also tells you what the drop is.
The drop from what? Sorry.
From horizontal.
Right.
If you
Okay.
want to call it that.
So what you are saying, that the water level will drop from the horizontal level. There's two. You're saying there's two different levels, right?
Yes. Yes. And it's a
Okay.
It's a continuous drop, but it starts out being incredibly small, where it doesn't really drop.
Right. So
And then
can we
as you go
say
further and
can we
further
say
along,
that
drops
if
much
we
more
get a mile water level?
you have a mile water. You're standing on if you're standing on your canal, that's a mile water level. You don't
Okay.
need to
So
set up
are
tubes
you
or anything
saying
like that.
then a mile away from where I stand, the water level will be 8 inches lower?
Yes.
Lower than the horizontal level, or lower than the water level?
Lower than the level established by your auto level, which is basically eye level.
Basically eye level. What are you talking about?
Well,
if you set it up at eye level, but I mean eye level's eye level, and the auto level establishes
your
a
auto level gives you a
horizontal.
Right, it gives you a horizontal reference, just like spirit level helps me level a picture. It gives me a horizontal reference.
Okay, and there are professionals, right, that can move that horizontal level. We'll call it a benchmark, right, to another place a mile away.
Yes, and then they will set up a different reference level.
That would be transposing the horizontal, the same horizontal from a benchmark over to find a new benchmark at a different place in reference to the horizontal, right?
Yeah.
Yeah.
One, I'm not organized, so I can't find my other picture, but also I'm out of time. But
Okay, you're out of time. I did send you your picture back, so when you come back, A and B for us.
Yes, please.
A and B for us next time you come in.
I may try to make a video or something, but it's good because I understand your confusion, but I also
there is no confusion. You just put up a blank picture, and you
it's
put
not a blank picture.
lines.
The idea was to just be a proof.
Hello. Well, A and B for us. How about that?
Okay, yeah, you're right. There were no labels on it, and talking through it isn't the way to do it. So,
thank you.
Especially because I don't have a mouse pointer or anything like that. All right, I gotta go.
Thank you. Have a good day. See you next time.
See ya.
I gotta say, you're totally blowing my mind right now.
You twat. How do we know the Earth is not flat?
We don't. It's flat.
Understanding of the world in which you live, then of course the world looks flat. The world looks flat. The world looks flat.
Neil.
Bitch. You twat.
I gotta say, you're totally blowing my mind right now.
That's what I do. 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 What I do.
But I don't have much patience for anyone who denies that this challenge is real. We don't have time for a meeting of the Flat Earth Society. Flat Earth Society.
My friends, these people are so out of touch with science. You don't need to be a scientist to know that the Earth is round.
They must have been founding members of the Flat Earth Society. They would not have believed that the world was round.
Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash.